Hey everyone, thanks for joining us for the next session of our Python and AI Level Up series on structured outputs. My name is Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter and moderators to answer live. Our session is being recorded. It will be available to view on demand within 24 hours right here on the Reactor channel. With that, I'd love to turn it over to our presenter for today. Pamela, thanks so much for joining.
Hello, everyone. Welcome to the Python AI series. We are now at our 5th class in the series. We've already covered LLMs, vector embeddings, RAG, and vision models. If you missed any of those, you can go back and watch the recordings, grab the slides, go through the code. All of it is available and linked, and it will be available hopefully forever and ever till the end of time. Today, we're going to be talking about structured outputs. And then we've got 4 more classes after today where we're covering topics like AI quality, tool calling, agents, and MCP. So if you haven't yet registered for the series, go and register for it. We'll put that link in the chat so that you can get notified when the next streams are starting. So today is all about structured outputs. And this is it's a super helpful technique that you can use with LLMs. I don't think enough people know about it and take advantage of it. And it's just really, really helpful. So I hope you stick around and learn something from today's talk. So we're going to be talking about what are structured outputs? How do we use them? How do we define our schemas? How can we do things like an entity extraction with that structured outputs? We'll have 2 different repos that we're working with today. And as usual, you can follow along for free in GitHub Codespaces with GitHub models. So the first repo we'll be using today is one that we've used quite a bit, which is the Python OpenAI demos repo. So what you can do is follow the link that we'll put in the chat. And this will go to the GitHub repo. And then on the repo, what you're going to do is click on the code button. And let me actually delete my current code space so you can see what it looks like. All right, so you click on code, and there you see a local tab and a code space tab. You can check it out locally if you really want to, but if you do that, you are going to have to read the README to see how to configure your environment variables correctly. What's easier and what we recommend for most people is to open it up in code spaces where everything will be set up for you and you don't have to configure anything at all. So I'll click Create Code Space on Main. And this opens up a GitHub Codespace, which is a VS Code in the browser that has the project environment set up with all of the Python packages already installed for you. And when you're inside GitHub Codespaces, that gives you instant access to GitHub models for free. And that's what you'll be using in this environment here. Okay, so that already started up. Generally, you want to give it a few minutes to start up. All right, so if you want to follow along, do those steps in order to open that repo in Codespaces. So we're going to start off with just really quick review about calling LLMs, right? This going back to our, very original talk. So when we want to call an LLM, what we typically do is, make a request through the API. So here I'm using the chat completions API from OpenAI. I specify the model that I'm using. I can specify the temperature for many of the models. And then I pass in a list of messages, right? I'm like, okay, here's my system message that says generally what I want, out of this interaction. And then I can pass in a series of user messages and a system message. So here I'm like, okay, you're a helpful assistant that makes cat references. And then the user wants a joke about a hungry cat, right? So then we get back the response. The response is full text. And so, the response in this case is a joke. We could get back an answer. We could get back a summary. We could get back a novel. Like we could get back any sort of, text that we want, right? And I can actually, run this code here. This is chat.py. in this environment, in this repo. So let's see. So I go and run it. And this time, this one actually says write a haiku. So we'll get back a haiku instead. And so there we go. We've got a response back from GitHub with the haiku. So that's how we've been using LLMs for a lot of our classes so far. Is we send in some messages and we get back text. Now, the thing is, sometimes we want something more structured than text, right? Like instead of wanting a haiku or a poem or essay or a novel or a joke or an answer and a summary, we want a structured output that has specific fields in it, right? That we can then use for further automation. And so that's why we have structured outputs, to give us an alternative to text. And this is really useful when we start using LLMs for like workflows and automation, and not using them just for, kind of chat interfaces. Chat interfaces are great. I love them. But there's a lot of helpful uses of LLMs for background jobs and workflows, and their structured outputs can be really helpful. So what actually are structured outputs? How do they work? So OpenAI introduced them in August 2024 in their APIs. And since then, they've been adopted by many of the LLMs and APIs. So generally, if you're using a model, there's usually some way to use it with structured outputs. And the idea is that you tell the LLM, hey, this is the schema, this is the shape of the information that I want coming back from you. And that model will send you back a result in that schema. And in this case, we're specifically using something called JSON schema. So JSON schema actually describes the form of JSON, which is a kind of object format, and says, okay, this object needs to have, in this case, like it needs to have a name, it needs to have a date, it needs to have participants. And they each have their types, right? So the name is a string, the date is a string, the participants is an array of strings, right? And they're all required. So we're describing what the object looks like that we want to get back, right? So that's the idea, is that we describe the schema of the properties that we want, of their names and their values or their types. And then the LLM will give us back the data in that format. So how do we actually define that schema? So here I'm showing JSON schema in JSON. The thing is that JSON schema it's a little annoying to write. Most people don't really enjoy writing out JSON schemas. It's a bit of a pain. So what we normally do in Python is that we use this package called Pydantic. And it is a package for data validation. It's used a lot with APIs. If any of you have used Fast API, you have probably used Pydantic, because that's how Fast API defines, API inputs and outputs. So in, when we're doing structured outputs, a lot of times we find it easier to use Pydantic in order to describe the schema, right? And then the packages can turn these into JSON schema for us, right? So in this case, instead of, this schema here, this whole long JSON, I can do the same thing with just this Pydantic BaseModel class instead. So I'm like, okay, I'm making a class calendar event, and it inherits from BaseModel. So it's a subclass of BaseModel. And it has a name, which is a string. It has a date, which is a string. And it has participants, which is a list of strings. So this is really nice, especially for, Python developers, that we can define these, the schema that we want using these Pydantic classes. So how do we actually use that in our calls to LLMs? So for today, we're going to be using the OpenAI package primarily. So in that package, there's a couple different ways you can do it, but here we're using the OpenAI client, and then we're using this method chat completions parse. And in that method, we pass in the response format, and that needs to be a Pydantic model. And then when we get back the response, we actually want to check to see if there was a refusal. So a refusal, if we get back that there was a refusal, that means that for some reason it wasn't able to adhere to the schema. So, we want to definitely check for that first. It's basically like error checking, right? If there's a refusal, that means it didn't succeed. It didn't produce an output that matched the schema. So we're not going to be able to use that, use this output. If there wasn't a refusal, then you should find this parsed object here, and that will be the actual Pydantic BaseModel class here. All right, so let's actually run that code in the repo. So that's the structured outputs basic example here. And so we're connecting with the OpenAI client. Let me make it as big as possible. We can also get rid of the mini map. Okay. All right. So we connect to GitHub models with OpenAI. Then we define our calendar event. That's a subclass of Pydantic BaseModel and has the types. And then we're telling it to extract event information. And this is the actual sentence we're passing. It says, Alice and Bob are going to a science fair on Friday. And it says, okay, we want the response to follow this format. Then we check to make sure that that we didn't get a refusal. And if so, we can print it out. So let's go ahead and try this. And here we get back the actual Pydantic object. So this is like really nice because then we can, this is already in the form we want, right? So we can actually say, print event dot name, print event dot date, print event dot participants, right? So everything is in a highly usable format already. We don't have to do any sort of crazy parsing and validation ourselves. It is already validated. It's already in a format that we can easily extract exactly what we want from it. So this actually opens up like a whole range of possibilities of what you can do with LLMs when you can get back the structured output, right? Before structured outputs, people would do like all sorts of things to try and like parse out text from LLMs using, like regular expressions or trying to get the LLMs to output JSON, and it would like kind of do it all right. But now that we have structured outputs, now we can fairly reliably get back these formatted data from LLMs that we can then build on to make interesting things. All right. So that was our basic example, our basic Pydantic base model. I saw a comment that this is like object-oriented programming class. That's great. Yeah, we are using object-oriented programming here. I do love object-oriented programming myself. I was raised on Java from my dad. He was a big Java user. So I'll always have a soft spot for making subclasses. So here, yes, we are making a subclass of the Pydantic base model. And we're going to get even fancier with our classes soon. Because we're going to talk about how we can extend our schema to do more interesting things, right? To go beyond the basic lists of names and types. So the first thing that's often helpful to do is to describe each of the properties that we want to come back, right? Because if we just say name, it has to guess what name means, right? Like, is name the name of the event? Is name the name of the people? If we say date, it has to guess what format it's going to be in, right? So generally, I always recommend putting a description for each of the fields that you want back that gives the LLM more information about what that field is, the format of it, an example. It really improves the results in my experience. So let's look at what that actually looks like in the code. All right, so now we're going to use this additional Pydantic class called field. And then in our actual schema, I've added, so instead of just saying string, I say string equals field. And then it starts with this ... ellipses. And then we pass in a description and say, okay, this should be a date in the format of, year, month, day. So this time when I run this code, we should get back a different date. Because you see before the date was Friday, right? Because it kind of just guessed at what date form we wanted. But here we get it back. It says 2025-0401. Now that's super interesting, right? Because that, how did it get that date, right? Well, I did say in here, extract the event information. If no year is specified, assume the current year, 2025. And then it says Alice and Bob are going to a science fair on the 1st of April, right? So nice thing always to do with stuff like this, if you're dealing with dates, is actually give the LLM exactly today's date, right? So you could call like date time and say, hey, today's date is this date. That will always make your LLMs much more accurate with date extraction. But here it got it correct, right? 2025, 1st of April, right? 2025, 0401. Right. And if I change this, like, okay, I want a different format, or also, let's see. So that looks good there. Yeah, that's, so if we do this, is it going to do, ooh, look at that. It actually didn't obey it this time. It should do. So I was hoping it would do like 25. Let's try it, like e.g. 2025. I don't want to tell exactly the right answer. That's too close. That's too good. 20131. Okay. Maybe this sort of date format just doesn't really ever happen in the world. There we go. So this time I got it, right? So there you can see that, sometimes you have to give it even more of an example, especially if this is like a weird thing to ask for. If nobody's ever asked for this before, then it's not going to give back. Or it can be like, year, or, month, day, year, right? So let's try that. And it definitely does help to give it an example. So here we go. We'll try this one now. And there we go, April 1st, 2025. So definitely, give it as much information as you can, right? Give it an example, give it the format, give it all the information that you can. All right, so here we go. And remember, so what's happening behind the scenes is that it is turning it into a JSON schema. All right, so it's using this Pydantic model, turning it into a JSON schema, sending that to the API, and then when it comes back, this OpenAI package is using Pydantic in order to like do an extra bit of validation to make sure that it did adhere to the schema, and then giving it back to us, right? So I'll show you a little trick. If you're ever wondering what is actually going on, like behind the scenes with the OpenAI passage library, what I normally do is I set the logging level to debug, and then we're going to ignore that. I'm going to run this. Let's see if I can show you. Okay, so this shows us all the stuff that's going out here. I'm hoping it's going to show. Okay, great. So here what you can see is this is the actual schema that went out. So response format is a JSON schema, and here's the actual schema. And you can actually see that now the date field has a description, right? And the other ones don't. So I very often turn on debug mode because I always like to see behind the scenes, see what's happening. So this shows us exactly what, what got sent over the wire to the API. And so we can see how that Pydantic model got turned into a JSON schema. So here it's the OpenAI package that is turning it into the schema, right? So it has functionality that turns into a schema. Well, the OpenAI package is using Pydantic to turn into a schema because Pydantic already has support for turning a schema. So OpenAI can be like, hey, turn this into a schema. Great. Now we're going to pass it back to, over HTTP. Okay. So hopefully that helps a bit with understanding kind of the magic. It's not magic. It's just code that we couldn't see before. And now we can see it, right? Okay, great. So let's keep going. All right. So we're going to get a little fancier. Now, another thing we might want is like, okay, actually, instead of date, what we care about is just the day of the week, right? And the day of the week, there's many different ways you could express the day of the week, right? You could say it with short, like sun, mon, twos. You could say it in different languages. You could say caps, right? How do you want back the day of the week? So if there's only a limited list of values that you ever want, then what you can use is a Python enum. So an enum is something that can take on just a limited range of values, and you can say what those values are, and then you'll get back just those values, right? So if we go to the next examples, the structured outputs enum, here we have to import enum from Python, from the standard library. So it is just part of Python. So basically, like sometimes Pydantic has to create their own classes for things, but if they can use something from Python standard library, then they do. So in this case, we're using enum from the Python standard library. And we say, okay, this enum is an enum of type string. So there, with our object-oriented programming here, we're getting a little fancy. We're extending from both of these. So it is an enum of type string. And we've named it the day of week. And each, what we do is we say, okay, this enum, has this value, and this has this value, and this has this value. And so you can either, when you get it back, you'll get back this, but you can get back the value of that. I don't think I'm doing a good job explaining enum. So I recommend checking out the Python enum documentation as well if you haven't worked with enums before, because it's also something you can just use in your everyday Python code as well. That can be helpful. Okay, so then what we do is say this time date is actually going to be an enum, right? And let's go ahead and run that and see what we get back this time. All right. And this time we get back that the date is the actual enum, instance there, right? So if we did print event.date, let me just show you specifically what it'll look like. Okay, so it says day of week.friday. So if you want that string, you actually have to say event.date.value, and that will give you back the string. And there we get Friday, right? And the reason that it's helpful that it gives back the actual enum instance is that what you can do is you can keep it as that, and then you can say if event.date equals day of week.friday, right? So if you want, you can have it so that your code never touches bare string values, right? Because that can be a little risky when you start just having strings around your code, because then you're assuming that you always type those strings the same way. And, things happen. Sometimes people will have a lowercase Friday or uppercase Friday, right? So if you are dealing with strings like this, it can make your code a lot safer if you always refer to them, wrap them in an enum, and then you can do all your checks saying like, oh, okay, is it actually this string, right? And then we can conditionally say things based off of that value, right? So yeah, generally, if you can, it's nice to use enums, and it gives you the ability to have nice clean code like this. All right. The next thing we can do is that we can also nest models inside each other, right? And this makes sense because if we were doing like JSON, and JSON can be deeply nested, right? So, the LLMs can basically give us back JSON, and we should be able to do anything we can do in JSON. So in JSON, you can have deeply nested JSON. Same thing here is we can say in our JSON schema, like, all right, this object in the schema is actually another, sub object inside of it. So here, what we're going to do is that the participants, instead of a list of strings, is going to be a list of participant objects, right? So each participant has a name and a job title, right? And so then we can get back a list that has participants inside of this, right? So we can get back deeply structured data. So let's open up that one. That's structured outputs nested here. And you can see we've got two subclasses of base model, and this list refers back here. So we do have to put the participants first, because here, if we did like this, what you can see is going to happen is that it's confused, because Python, the way Python is evaluated is that it reads everything in order. So you generally either need to order things correctly, or I think what you can do is you can go like this. Oops. And it will get done correctly. So just something to keep in mind in terms of how you order your code. Let me try that out. I think we can do that. So here we're having it. We actually gave it. So yeah, that worked there, right? So your options are either, I think it's cleaner just to order it with putting participant at the top. But if you're ever in a situation where you can't order it that way, then just put the class name in quotes, and Pydantic will basically evaluate it and figure it out. So here we get back. So we passed in Alice the carpenter and Bob the plumber this time. And so when we got back the results, we got back a list of participants. So there we go. All right. So that's what we're going to show in terms of Pydantic. There's a few more things you can do in Pydantic as well, but that covers a lot of what you'd want to do. And I do encourage you to use all of those as much as possible and to add descriptions to all your fields in order to help out the LLM. It's just going to make your output more robust and better to rely on. So in terms of who supports structured outputs, it was first introduced by OpenAI for recent model versions. So we've got it in GPT-4o, GPT-4o mini, GPT-4.1, GPT-5. I should update this list. So basically, like if you're using models from OpenAI, it most likely supports structured outputs because at this point we've deprecated the models that don't. And now the cool thing is that also Ollama found a way to add support for structured outputs to all of their models. So they basically added it as a layer on top of their models that makes all the models try to adhere to the JSON schema. Now you're going to get varying results based off which local model you use and how small it is and whether it really adheres to the schema. But in theory, you can use structured outputs with Ollama with local models. If you want to try that, it should be possible. But generally, you're going to get the most reliable out of the larger models that have been specifically trained for structured outputs because they as part of the actual training of the models, they gave it the models this ability to understand JSON schema and to output in correct JSON. So now let's look at some situations where we could use structured outputs. And for this one, we have another repo. This is our entity extraction demos repo here. So if you want to follow along, once again, you'll go to this repo and create a code space for it and give it a few minutes to start up. We will share this link in the chat so that you can follow it and get it running. So when do we use structured outputs? The big case scenario we're going to show here is what I call entity extraction, basically meaning, we have some unstructured data like documents or images or graphs or whatever, and we want to extract more structured data out of that unstructured data, right? Another simpler use of structured outputs would be any form of classification where you want to, give it some data and you want to say like, is it X, Y, or Z? And you can just tell the LLM like, hey, I only want to know if it's X, Y, or Z. And then a related thing is to do OCR. So we talked about this yesterday in the vision models talk, but basically you give it an image and say, hey, extract the text from this image, but output it in a structured way, right? So these are all basically the same idea, is that we have unstructured data and when we want to extract some sort of structure out of that unstructured data, right? So we have a variety of examples here that we'll go through in the repo to give you an idea for what you might use this for, what kind of data formats you could use it with, and also just show more examples of interesting schemas. All right, so now let's just go through these examples. All right, so here's the repo. Let me make it real big. So the first one we have is extract GitHub issue. Let me make this bigger. Let's get rid of the mini map. Let's ignore that. If you ever see anything pop up in the code space, just click the X and don't worry about it. I've been trying to get it so that code spaces don't pop up anything, but we haven't gotten rid of all the pop-ups yet. So if you see a pop-up, just exit away. All right, so what are we doing here? So we are going to fetch an issue using the GitHub API, right? So we'll actually get back an issue here. Oh, all right, that's whining. Okay, so we're fetching an issue from the API. We're getting it back, and we're getting the body of the issue. All right, this thing. Oh, okay. Okay. What is happening? All right. my VS Code in the background decided to freak out. All right, VS Code, calm down. Happy? Okay. All right, ignoring that. So we're fetching an issue and we're getting back the body of that issue. So this body is just text, right? It's going to be whatever in the main body of this issue here, right? So we're extracting out this body here, which is an issue description. And we're taking that text and say, okay, extract information from this issue markdown. So here, this is, pretty basic example, similar to what we've seen before, right? So description, we said, okay, we want it to be a 1 to 2 sentence description of the project. Because here's the thing, if you ever ask for a free text string, like description, you can get like sometimes LLM's gonna write like a whole darn essay, right? So if you're asking for a description or a summary, something like that, you really want to be specific about how long it should be. Because, the LLM will tend to vary quite a bit in how verbose it is. So here I said it's a 1 to 2 sentence description. And then we're using an enum in order to categorize it. And so you can also do like forced categorization, right? So you kind of basically are doing classification by saying, hey, you have to figure out, is this a bug report, feature, documentation, or regression, right? So I'm actually doing like a forced classification here as part of this extraction, right? So it's interesting. We're basically like using common capabilities of LLMs and we're combining it all here. Like, so title is just a plain extraction, right? The title is there. It's going to, it can take it out. Description is using like the ability of LLMs to summarize. Type is doing like a classification. And then operating system is, like an extraction. So let's go and try this out. GitHub issue.py. All right, and what we got back is it says, okay, so it made a title. We got a description, just a 1 sentence. It says it's a bug report, and it says the operating system is Windows 10. So this is useful. Like if you wanted to like do a quick summary of all of the issues in a repo and, kind of categorize them in different ways, you can just, write something using an LLM and structured outputs and just get this like, really high level overview of everything that's happening in your repo, right? The next example we have here, X that, is this one. We're going to look at a whole README, and this was, I think, a hackathon README here. And this one actually, the content looks like it's encoded. So we actually have to do a base 64 decoding here, right? So we get back the contents and then we decode it. And this one's similar where we're asking for it to do some classification. And this was one that I actually used because we had this hackathon and we got like hundreds of submissions, and all the submissions had GitHub repos. And I needed to turn this into a form that we could use for judging. So I went through all the repos, and for each of them, I used the LLM with structured outputs in order to categorize them so that we could split them up for judging, right? So here, this one's a little fancier. We've got some more enums here. We've got a list of enums. So how did we do this one? So so these are all enums. So you could also have lists of enums, right? So you can say, all right, give me back, any of the things from this possible enum, right? And so that's nice, so that we can have it basically like, check a box and be like, okay, which of these boxes would you check for this thing here? All right, so there we've got, extracting some stuff based on text. Now we often get asked about, how do you like scrape web pages? How do you turn web pages into useful information? So here we have an example, extract webpage.py. It uses the BeautifulSoup package. The BeautifulSoup package is a very popular package for scraping web pages. It works as long as you're scraping a web page that is not using JavaScript. And that's basically statically rendered. So what we do, so here I am scraping my own web page. It's a blog, and I said, okay, we're going to fetch that web page. We're going to parse it. I'm going to extract out some bits of the HTML. So I got the title, I got the body, and then I'm going to tell the LLM to extract information from the blog post. So I'm asking for title, summary, and tags. So let's try this out. So you could use this approach with, with BeautifulSoup, with any web page that is statically rendered and isn't using a lot of JavaScript to fill in the content, right? I'll show an example later of using structured outputs with a JavaScript page, because that gets a little more complicated. Oh, wait. Okay, fine. I see a question now. What if it's using JS? All right, let's just show it right now. Yeah, I should anticipate that. So I don't have the example in this repo, but I do have an example open here that I thought people might be interested in. So let me just run it so you can see what it's doing, and then we can talk about it and look at the code. So Python invitations manager.py. All right. So what this should do is pop up a browser, and it's going to use the Playwright Python package, the Playwright SDK, in order to navigate the browser. So I look at my hands. My hands are not doing anything, right? It is doing all the navigation on this browser. So it opens up the network tab. It goes through and it looks at each of the invitations that I've received. And for each of them, it's sending them to an LLM. So once again, I'm not touching anything. It's sending each of them to an LLM, asking for a structured output that says, hey, should we accept this connection or not? Basically, if it's a technical person, it accepts. And if it's a recruiter, it rejects. Sorry, recruiters. And yeah, so it goes through and it's just going through each of them and using structured outputs to decide whether it's a yes or a no, and making that decision. So this is one approach. If your web page you're trying to work with a web page that is fully rendered with JavaScript, is to use the Python Playwright package in order to work with it. Okay, so it's still going there. Okay. All right, so it decided to accept all of those. That's great. And I can get a summary there of what decided. And these are all, outputs from the LLM. So let's look at the structured outputs that were used here. So once again, so invitation, right? So for each invitation, it grabs the name, the profile, the job title, and whether there's any mutual connections. And it does that based just on what it found in the HTML. And then it's the decision, right? So what is the decision? Well, the decision is an action and a reason. So I always ask agents to give a reason so that I can understand why. So the action is either accept, ignore, or undecided. So ignore means it's actually going to click the ignore, so I'll never see that again. Undecided means it really couldn't decide, so it's going to have me do that, right? So I can still be in the loop, and then I'll just go through anything it's not decided on. And then we have the reason, right? So yeah, and so then I pass that to this agent. Now this is using Pydantic AI, which is a different package for working with LLMs. And Pydantic AI is from the team that made it at Pydantic, so it works very well with Pydantic models, as you would assume. But it's the same idea, right? You can do this with any like at this point, any of the SDKs should support structured outputs. So whichever SDK you're using, whether it's OpenAI or LangChain or Pydantic AI or whatnot, agent framework, they'll all have some way where you can say, hey, I want the output type, the output format to be this model. And there's a bunch of code here that's doing the Playwright stuff. It's kind of nasty to look at because it's a bunch of like HTML, manipulation. I have to force the scroll when I'm at the end of the scroll and all this stuff. But that's the general idea. And let me share that in the chat for anyone that wants it. I'll ask Anna to share that URL in the chat. Pablo says, "What about my feet?" You're right. My feet were doing all of that. I was just cheating and using my feet. I wish I did go through a phase once where I tried to type with my toes, but I gotta say it's like really surprising. Well, maybe not surprising. It was hard to type with my toes. I gave up on my toe typing phase. All right, great. So we extracted from a web page. We saw doing it with BeautifulSoup, also doing it with Playwright. Bit more complicated, but still very, very doable. So now let's talk about documents. All right. So we all, we have all these PDFs lying around, and now it's exciting that we actually have, ways of processing those PDFs and reasoning on them and extracting lots of information from them. So we can use structured outputs to extract things from PDFs. So the example we have here, let me actually open the PDF locally so you can see what it looks like. Let's see, example PDF. Okay. So here is a PDF. You can see it's split over 2 pages, kind of awkward. This is for some stickers that I ordered. But inside here, you can see it's using this kind of table in order to say what the price was, right? So we're going to see if we can extract the relevant information from this PDF. Let me close that one. Okay. So how are we going to do that? So opening this up here. Right. So from the, for our model, we're asking for the total, the shipping, the payment method, the items, and the order number. And the items are actually a list of items, which each of them have a product, price, and quantity. So here we are assuming a lot about this PDF. We're assuming that it's, it is a receipt that has items and kind of follows this rough format. But you may be processing a lot of receipts that are similar like this, right? So the first thing I did was I used a package in order to convert this to Markdown. That's generally going to be the first step when we're working with PDFs, is to turn it into a format that we can send to the LLM. So a popular approach is to turn it into Markdown. Here I'm using PyMu PDF for LLM. You could also use Markdown from Microsoft. You could use Dockling, which is from IBM. You could use PDF Plumber. It's another one I got recommended today. So there's many libraries that can take a PDF and turn it into Markdown that the LLM understands. So then we say, okay, extract the information from the Markdown version of that PDF, right? So let's go ahead and run this and see how it does. All right, so we got back and we can open up the PDF and look at this and see if it got it right. It says 242.05. That looks good. Shipping was free. Payment method credit card, and then we have the items, and that has the information there, and then the order number up here. So there we go. So it extracted everything pretty well. This is using the GPT-4o model, by the way. You can try with different models to see if you get varying levels of quality with the extraction. But here it did a great job. Oh, I see a question. Can you define optional and mandatory elements? Yeah, that's a good point. So if you want to make something optional, let's see, the way we're going to do that is optional. Did I already do that in any of these? Did I really not do it in any of them? Nope, I didn't. Okay. All right. So it should be that we say typing import optional. Let me organize my imports. There we go. All right, so from typing import optional, that's from the standard library. And then I'm going to go down here and say optional int. I think this is how we do it. If you're never, okay, there we go. Say no. Oh, okay, don't do that. Sorry. We're in modern Python, so we shouldn't do that. We'll say int or none. Okay. So that should be the thing that marks it as optional. Now, of course, if we're not sure, remember what we do is we're going to set our logging to debug, and we're going to look at the schema that goes out over the wire and see what that schema looks like and see if it has marked it as optional, right? So we were looking for all right, so it said order number can be either integer or null. So that looks correct. That's at least one way of marking something optional. It might be that there's another way as well. I'd have to look at the Pydantic docs. But we have seen that, making this change here has resulted in a change to the schema where it says, oh, order number could be null. Yeah, that's a great question. Let me also, I just feel like we should double, docs.pydantic. Pydantic. This is Pydantic AI. I just want Pydantic models. Pydantic model. Optional. All right. So if you're ever unsure, general approach is to go to Pydantic docs and check out what they say here. Oh, optional is kind of a popular thing. Types, fields. Okay. Can we say optional here? All right. I got to dig into see if there's if that's definitely the best way to do it, or if there's also other ways as well. It's a great question. All right. We will dig into that to make sure this is the optimal way of doing it. It might also depend on the model and what it was trained with. All right. So next kind of document we might want to process would be Office documents, right? Like docx, PowerPoint, etc. So I have an example document that I just generated yesterday, and can just open this up here, right? And here it's just a document that's got some sections, it's got a title, it's got an author on it, right? So what I'm going to do is parse that document using structured outputs. So go ahead and open up the extract word example here. And this one is using the Markdown package from Microsoft, right? So since it's from Microsoft, it's pretty good at parsing Microsoft documents. So it can understand stuff like docx and PowerPoint and all that stuff. So we can construct our Markdown class, and then we tell Markdown to convert this file into text, right? So basically it's giving back Markdown here. This is like Markdown content here. And then we pass in that Markdown to the LLM and say, all right, turn it into this, document metadata here. So let's go ahead and run this. So you see both of these are using the same approach, is that we have a document type, like a binary document type that an LLM doesn't understand. We need to turn that into something that LLM understands. So in this case, we're turning it into Markdown. Another approach, like the one I showed yesterday, is that you could take a PDF or even a document or a PowerPoint, and if you can turn each page into an image, you can also pass that image to the LLM and have it extract things based off the image, right? But the general point is that, these models only understand, text or sometimes images. And so whatever format your file is in, you need to turn that into a format that the LLM understands before you can pass it off to the LLM, right? We can't directly pass off a PDF. We have to turn it into something it understands. So here we did get back the title, author, and then all of the headings. So that worked out. I see a question. Does it also get information from tables in a docx? So it probably could. You'd probably just you need to figure out how to ask for that. So you might do like tables, and that would be then you'd have to make like a table. Like you have to decide like how you're gonna represent that headers, rows. That looks great. All right, so we're gonna do tables, list table data, right? In this case, I don't remember if I had, did I have tables in this document? Let me look. Because that is a good test. Tables mean, okay, so there is a table here. All right, so let's see if it can extract it, right? So, okay, we said a list of table data. All right, let's give it a go and see if it can extract it. Great. All right, so we got back tables, and it says, we've got headers, we've got rows, and that looks correct. So it did a pretty good job at extracting tables from the document as well. So I see the question, is processing the text faster than processing an image or of a PDF? That's a good question. I would, my gut is that processing text is going to be faster. And so I would tend to use that and only use the PDF to image for something that I couldn't reliably turn into Markdown, right? Like if it was like a highly, highly visual thing, like a PowerPoint with lots of diagrams and stuff. So my assumption is that it's always going to be faster to use text and, generally more reliable. But that does mean you need a good way of turning it into text, right? So I think if you have a really good pipeline for getting that particular document into text and that document is mostly text, then it makes sense to do that. But if that document does have images and big figures and visuals in it, and you're going to lose that information, when you're turning it to text because whatever you're using doesn't support, retaining the figures, then that's the point where you would want to, pass in an image instead so that you don't lose any information, right? So so I would consider all that when you're deciding for a PDF. Are you going to convert it to an image and pass it in, or are you going to convert it to text and then pass it in? All right, so we dealt with documents. Now we're talking about images. So let's look at a couple image examples here, right? So we have this graph of tree cover. We looked at this graph yesterday as well. So we can, pass that to the LLM and say, hey, describe this graph for me. So what we're doing is we're opening up the image, we're converting it to base 64, and we're passing that base 64 encoding to the LLM and asking it to extract all the information according to this schema here. So here we get the title, we get the description, we get x-axis, we get y-axis, and we get a legend. We also had an image with a table in it, just following up on our table question, right? So the one with the table is this one, right? So it'd be interesting to, compare, because this was originally a PDF, right? So I could try to turn this one, it's getting way too small, turn this one into Markdown, but it's using kind of like a funky table, which has headers and stuff in it. So who knows if we'd have to test the packages to see if they actually do a good job of turning this into Markdown. So this is the one where I'm like, okay, well, it's, maybe in this case, it's easier just to turn into image, right? Once again, you really got to test it out on your own data and see what works best. Luckily, you've got different options that you can use. So with this one, we're going to pass it to the LM. And here, in order to represent those tables, I, kind of said, okay, I'm looking for these 3 lists, and they each have this information in it. All right, so we can run that and see how it does with extracting that more tabular data here. All right, so we're running that. And so the thing is, when you're coming up with these models, you have to figure out how generic they should be or how specific, right? In this case, I made a really specific model. So it's not this model isn't going to work just for generically pulling out any tables from an image, right? I made it super specific to exactly this document. And that's up to you, because it depends. What are you processing, right? Are you processing a lot of things that look the same, that have the same fields that you're trying to pull out? Or are you processing more generically, where you need to just say, hey, if there's any tables extracted like this, right? So that's just up to your scenario, whether you're going to get really specific or really generic. But here you can see we got back all this nice information that it extracted out. So if I was going to do an evaluation of whether this was a good approach, I would manually create the ground truth data and say, this is exactly what it would look like if I was doing this manually. And then I would ask the LLM to do it and then compare and see how good of a job does it do. I know for this one in particular, depending on the model, sometimes it will basically kind of hallucinate or make typos in some of the fields where it couldn't quite read the text. So you definitely want to, run some evaluation, have some ground truth where you can see how well the models do. All right, so those are what I want to show. We do have 5 minutes left today, which is exciting. So I can answer a few questions during that time. So let me go ahead and see what questions we have here. So Pablo asks, what do you suggest to verify how the model is doing it? You want percentages of confidence. So I would suggest, setting up evaluation with ground truth, right? So, the example I was just showing, you want to actually have a human come up with what it would look like if they were hand transcribing this. And then you would, run the LLM on it and see how it does in terms of the accuracy, right? And see if it misses anything. Because that way you could try out new LLMs, right? You'd be like, okay, well, this is how it did this is how this LLM is doing. We just saw a new LLM. How does this LLM do, right? And you can also try different techniques, right? Like you could try, instead of doing the image, you could also try like hosted services like Azure Document Intelligence. But the first step is to have some sort of ground truth that a human made that is actually true, right? And you want to have some diversity in that ground truth as well, right? Here I have a single table, but you want to have a single image, but you want to represent the different kinds of inputs that you expect to get, and make sure it's really representative of the real world, right? Like I went to a talk the other day with somebody who makes customer support bots that have voice inputs, and they were showing the examples that they test on. In their examples, they actually have like this tool that generates background noise and generates, voices with the accents and voices that are shouting amongst background noise, right? You have to like simulate all the real world scenarios that you think you might get, including like the edge cases, the things that can be more messy, right? So ideally, you come up with some ground truth that has a diversity of your inputs, and you use a human to transcribe that originally, and then do comparisons. Let's see. Yeah, I see some example use cases. How would I approach dynamically categorizing responses without providing a specific list? So you could still, like, you can ask for something like class, like you could do like like response content, right? And then you're like like category equals we'll do like maybe list string equals field, and the field is going to have a description like list of categories for this content, suggest based off of your best approach, right? I don't know. So I'm trying to come up with something very generic here, but like generally you can come up with these really more generic things, and you just have to specify, like, are you looking for one thing? Are you looking for multiple things, right? Is it a list or is it a single string, right? And then give a description to give it more of a hint of how it should actually come up with this thing, right? So that might be the approach you want to take to really generic categorization, right? All right, let's see. All right, so I think we've covered the questions here. I see some people are working on different use cases, like a client typing in information from a handwritten ledger. Yeah, you can definitely test that out, right? Here today we talked all about LLMs. In yesterday's class, we talked about the multimodal models, but we also talked about using actually hosted OCR services, right? So don't forget that an LLM is not our only option, right? Like you can also be using actual OCR models, like Azure Document Intelligence, and there's other OCR models there. I think Dockling, I did mention Dockling. I think Dockling actually has its own OCR models too, if you want to try this one out for something more local. But remember, LLMs are not the only kind of model that can understand these things. So you also want to consider more traditional OCR models that can get information, right? So you want to compare all this stuff. The nice thing about LLMs is that they're something generic, they're flexible, and they've seen a lot of stuff. Like I was talking with somebody today who I was asking people like, okay, have you used any of these packages like PyMu-PDF and Dockling and whatnot? And they said that basically all of them failed with Dutch text because they were trying to extract things in Dutch. And I think a lot of these models like don't know a lot about the Dutch language. They haven't been trained on the Dutch language. So that's another issue is, where are you going to get the best support for your language if you are handling non-English documents, right? So especially for non-English documents, I would test out a range of options because it might be surprising to see like what works well for a non-English language, because it just depends on what they've been trained on. Okay, Sam asked, how do you balance flexibility, LLMs are creative, versus strict structure Pydantic is rigid. I mean, that's where I do stuff like like I give them like, the option to be more creative, right? Let's see, like this one. Like any of these like free text fields, the strings, you can get free text responses from. Like it tends to be pretty, these ones are pretty straightforward, but you can add more freeform things. Here I was saying, like, I do always like to add on a reason, right? So if you are using structured outputs as a way of decision making or even classification, even with classification, I like to have a reason, right? Like I was also writing like an issue labeler the other day, like for GitHub, right? So, with like a label decision, I'd be like, all right, I want to know, for that label, what is the actual label, and that would probably be like an actual enum, right? But then I also want to do the reason, be like, okay, and that's going to be the reason for it, and be like, the reason for that label. So there you get to at least see, why the LM came up with a decision. So yeah, so always recommend that. And if you do want, you can always ask for descriptions of things, right? So here we're asking it to describe the issue, and that uses more of the LLM's ability to, write out text, right? So I think you can just here you get the option, right? You can have the LLM actually write text if it makes sense for what you're doing, but you can also ask it for rigorous structured output, which is really powerful. All right, great. Okay, so we covered lots of questions. If you have more questions after this, you can post it in the Discord. You can also post it on the resources discussion thread here, and I can answer them, any follow-up questions there. And I will see you all tomorrow for AI quality and safety, and then we'll have all of next week as well. So thank you all so much for joining, and all the great comments and questions in the chat. Bye, everyone.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.